Hi, welcome to day one of my 100 days of Kubernetes. Today I will be looking at what Kubernetes is like, just having like a great overview of what Kubernetes is and why it's actually, important. So I have a few slides here. I think at some point I was actually waiting to have like something perfect before I put up a video, but I think perfection is just like something that steals your joy, sort of. So, okay, so let's get started. So today I'll be looking at traditional application development, modern application development, containers and VMs, as well as container orchestration. Or what Kubernetes is. So from Kubernetes IO, that's the official documentation page for Kubernetes. It says Kubernetes on SK8 is an open source system for automating deployment, scaling, and management of containerized applications. That's so much. So let's try to unpack all these things, just like definition and as well as understanding of what this means actually. Okay, so let's break that down. Kubernetes is open source and anyone can contribute. You can take a look at the source code and you can also contribute at, you can check out the GitHub repo. This is it. The second statement there says Kubernetes is a system for automating deployment, which means it has taken away the part where you have to manually create probably servers or application servers, or, after the developers have written the code, and then host people need to deploy, and then they need to spin up servers for whatever resource that you need to deploy. So you don't have to do that anymore. Kubernetes provides like a way for you to declare the states or that you want your resource to be, and then the resources will be created for you. I think eventually we would we'll still look at this. So management of containerized application. This is actually K-Hit's reason for existence. It was created to be able to manage containers at scale. And containers have been coming up a lot. So let's look at how all these things came to be. Today is just like for me to look at not just the history, but also why Kubernetes? Why is it such a buzzword? And what was in existence or what was in use before Kubernetes even came around? So how did Kubernetes come to be? Historically, applications used to be deployed on bare metal servers with an operating system installed on them. So it means that servers are, dedicated for just one reason. So if I have an email server, what that server does for the entirety of its lifespan is to serve emails to clients. If I have a web server, all it does is to serve websites to clients as well. So there, and servers are actually expensive machines. So it's kind of hard to realize that I'm paying so much to obtain a big machine where all I can do on it is just one application. I mean, what happens to the rest of the space? So here is a diagram. Sorry, don't mind my drawing skills. They're actually very terrible. So this is a traditional application deployment model where the host, which is actually the server or the infrastructure, has an operating system on it and an application on it. So this OS, you can only have one on it, or it could be Windows or Linux or Unix. And this application, it's actually possible for you to have more than one application, except that these applications would actually interfere with each other because they are all on one operating system and there's no isolation. So it's possible that if I say I want my single server to act as both a web server as well as an SMTP server, what happens is that one resource from one of these applications will actually starve the other one, because they are on the same hosts. They live in the same house, so there is no way they wouldn't, jam each other. Jam is not the right word. They probably run into each other at some point, and one is actually going to be at the losing end eventually. So that is why it's best practice on one operating system or on one machine have just one application. So because of these constraints, I mentioned earlier that it made it really, really hard for for you to be able to utilize your machine or your server to the best of its abilities. There's so much resource, but because you don't want interference between your applications, you actually can't do anything. All you can do is just watch it, one application, throughout its entire lifetime. Okay, so that's how a new technology called virtualization came to be. Okay, so virtualization is a computing technology that lets you create an abstraction over your host or on top of your host. So let's say I have the same big machine I was using before, but somehow I'm able to create something else on top of it. And this thing lets me create different smaller machines or smaller virtual machines. Obviously, I wasn't using all of my resources that were present on my infrastructure. And then virtualization says, hi, let me help you out here. I'm going to help you. All those resources you have, I'm going to compartmentalize. Is that a word? I'm going to help you divide them, into several different spaces where they won't have to interfere with each other. And each virtual machine, as they're called, will have to have its own independent, isolated environment. So this virtualization, so it lets you create software emulations of physical machines. So it means that could also be on my server, and I've actually created, I'm going to have a software on top of the base infrastructure, which is called an hypervisor. Hypervisor is what makes what makes virtualization possible. So if my base OS is actually Linux, and because of this hypervisor and virtualization, I'm actually able to create a Windows VM on top of it. I'm able to create um, another Linux VM. I'm able to create a Unix VM because none of them interfere with each other. Each of them acts like a single complete machine that doesn't even know that it is virtual. I think that's like the best and maybe scary part of it, because none of this virtual machines know that they live on top of another one. So they act independently. The only thing that probably the only thing that connects them is that base infrastructure, the base operating system, which they don't even need because each of them has its own individual operating system. So let me read this. This constraints led to the development of a technology called virtualization, which lets you create emulations of physical machines. The software instance called VMs are not aware that they have no physical components, as they just run as normal machines would. So a software component called hypervisor makes this possible, and you're able to create different OS on the base operating system. Each VM is created from the pool of resources the host VM has. The host machine, actually, this should be a machine, not VM. So that the base machine, the base infrastructure, they're actually dividing the resource that it has, because obviously I cannot bring compute resource or storage resource from outside. It has to be from what I have, and all the VMs that sit on top of this host machine, they are dividing that resource amongst themselves. This division doesn't mean that they interact. It's just that if I have probably 50 gig of memory, the addition of all the VMs I'm going to have, their memories can also not exceed 50. What matters is it cannot exceed that 50 gig that I have. So this is another very ugly drawing that I have. So I have my host already, and my host has its own base operating system, and my operating system has an hypervisor. An hypervisor is the software uh, that makes virtualization possible. And then I can have different virtual machine, several virtual machine. So here's my first virtual machine that has its own operating system and has an application running on top of it. Here's another virtual machine, has its own OS and application that is running on top of it as well. So each VM is completely isolated. They are sharing the base resource that the host has. They are separated from the operating system with or through an hypervisor. And isolation, yeah, that's what matters. But there is another constraint that comes from running things like this. So, because they act as normal machines, it takes a long time for them to boot up. Just like a normal machine would take the same times to load up, the same, maybe not all the constraints that we had in the traditional application deployment had, but it was just like a step further from where we're coming from. We're able to use our resources in better ways. So my next slide, we're still talking about KATS, just like an historical perspective of how Kubernetes came to be. Yeah. So although virtualization was a great way to manage your host resource, it came with its own constraints as well. Each VM had its own complete operating system, which means that it requires more system resources. It's like I said, it's pulling from what you had, your base infrastructure, the CPU, the memory, as well as the storage. VMs also take so much time to start